So, hello everyone. We welcome you back to today's session. And before we commence, if there are any questions to Desh on his three presentations and the projects he suggested in the last one, so we'll open the discussions on that, and then we will proceed ahead. So, from the participants, if there's anything they want to ask or interact with Professor Deshpande, you can please do that now. Aren't there any comments?
So, Professor Deshpande has especially taken the trouble of joining us now because yesterday he had to, leave at 11. So please, if you have questions, you can ask him those questions now, and then we'll continue with our regular schedule. So, do we have any questions? I don't see any on the chat window. I don't. Desh, is there anything you want to tell the participants from your behalf? You can tell them if you want to tell them something.
Yeah, I just wanted to, take that thought forward about the project that I had mentioned. If people would like to hear more about it, I can go and describe it. This is a case study of, population study of a pulsar and leading to estimates of the progenitor mass required for making a neutron star, getting to know about the rotation of the galaxy in comparison with the spiral density wave and things like that. So
yes, sure, Desh, you can share your screen and do that.
Okay, so what I'm going to do is flash previous work done on the same thing, same issue, and use that as a sort of template to describe what one has in mind. 1 minute, let me see. Okay. So let me share the screen now. Okay, are you able to see my screen?
Yeah, we can see your research. Yeah, we can see it. We can see your screen.
Right. All right. So this is a study of spatial distribution of pulsars in the galaxy and how that relates to the spiral structure of the galaxy. Okay, and as I said, the progenitors of neutron stars, which many of them will be seen as pulsars, are massive stars. They're born in the galactic disk, and they will also be preferentially born in the spiral arms at that time of their birth. Okay. So one basically gets to assess if they have the memory of where they were born. And if they do, then we can actually relate because the spiral structure would have changed over time, and they would carry the memory of when they were born. And of course, they will move with the matter with the differential rotation. Whereas the spiral density wave would move rigidly, rotate rigidly, where the tangential speed will be proportional to the radial distance from the center of the galaxy. Whereas differential rotation, as we know, for most of the distances well away from the center, is the tangential speed is roughly constant, very loosely stated. And so this, of course, the speeds, the tangential speeds become equal at some radius. It's called the co-rotation radius. And it's also an unknown for our galaxy in principle, but it can be estimated through analysis like the one I described. So this is the distribution of pulsars in our galaxy at that time when the study was done. There were not many pulsars available for this study, but you can see these dots in this diagram. Let me enlarge this. Okay. All right, so you can see the dots, and you can see the contours related to the spiral structure that is inferred from the electron density distribution for the galaxy. Also some data from the continuum observations, the intensity that you see in emission coming from the galaxy also helps you to pinpoint where the certain enhancements in intensity are, and they might be seen at the locations of the tangents and so on. So that is a separate subject, how to infer the electron density distribution. By taking one such model, and there have been refined models since, one can compare how the distribution of electrons tracing the spiral arms at the present time relates to distribution of pulsars which bear the memory of the spiral arm structure when they were born, when their progenitors were born. And so this is the idea. And so one takes into account all the rotations that are in play, and also accounts for the selection effects. This is one of the major issues in all the population studies. When we use a pulsar that we have observed, we know that there are so many other objects like that in terms of its luminosity and period and so on, that we have missed to detect. And that depends on the volume of the sky, volume of the galaxy that you have looked at. And you will have to know what volume you have really sampled based on the sensitivity and the area physically covered of the sky.
Right.
Was my audio getting disturbed? Or,
Yeah, there was a little bit of disturbance from someone, but it's fine.
Okay, fine. So I can continue possibly. Okay, so one has to account for selection effects. It's basically saying that we are not seeing the entire population, or we do not have information about the entire population, but we can estimate for every object seen how many such objects we might have missed. And that that requires knowledge of the sensitivities of the telescopes and the areas that they covered to basically estimate the volume that you have looked at. And you can do the volume scaling if the pulsar distribution is uniform over the entire volume, or if it's not, you can estimate what fraction you should have seen, and compare that with your what has been observed, and then scale it to what would be the total population of that kind. And that is done for every pulsar. And you can construct, the distribution of pulsars. And here, I think I will come to that later. So this is the minimum distance from the spiral arms, nearest spiral arms that one sees in the sample that one has. And you can see that they are not exactly at around 0. They have moved. They're away on either side of the spiral arms at the present time. So the present day spiral arms are compared with the pulsar population, which might have the memory of spiral arms at a shifted location in principle. So one accounts for this scale factors and so on. So essentially what one is describing here as a scale factor is the total volume, right? Or total, the density times density of pulsars times the volume, that is total, divided by the density times the volume that was observed. So, so when one does this, this is the sort of distribution of this sample in the magnetic field period diagram, which we have seen. And so now what one is going to do is take also weightage of the scale height in terms of things would have moved in the vertical direction, and one restricts it to certain range and weighs them in certain way based on the distribution that we have. Okay, and then one looks for basically the kinematics of the situation. We know that the rotation speed of the spiral density wave is given by this. It's a rigid rotation. So you will find that it has, sorry, this is the matter rotation, and spiral density wave will have a fixed rigid rotation where the velocity scales as radius. So one basically takes the present population and tries to rotate it back or rotate it forward depending on which way the spiral arms would have moved, and see if there is a match in the pattern that is predicted and what is observed. So when one does that, one gets, in this particular case, a bump or high correlation at some epoch, which is about 60 million years earlier. Okay, so it's just saying that the present population of pulsars matches with the spiral arm structure that you would have seen 60 million years ago. There is also this other bump which comes because of contamination that occurs, which is close to 0, and this will come because of a variety of reasons, which can be, some of them can be avoided, some of them cannot be avoided. So the significance of the correlation maximum is of course, affected by pulsars having random motions. We may or may not have the right scale factors, and of course one has to check the robustness of this correlation. And after having done that, one can actually use this to infer several things, and this is what is done. One can find out because one would have used the rotation model for the galaxy, the matter in the galaxy, as well as the spiral density wave, and they would match in speed at some radius, and that radius is called co-rotation radius. So you can infer that because that's what you use to rotate things back. And then this number of where the correlation is seen tells you the entire lifetime of which includes the evolution time of the progenitor and the lifetime it spent after being a pulsar. So you can subtract the pulsar lifetime from that and know the typical duration over which the evolution of the progenitor took place till the time of the supernova explosion. And this can be used to actually infer, because we know based on the masses how long it takes for the star to evolve. And so this is what leads to the 7 solar mass limit, 7 to 8 solar mass limit. So I will not go into the details of this because they are very difficult to make out in this on this scale. But so essentially, one has estimated that the population that we had at hand has an average age of 10 million years. One subtracts that naively from the 60 million years to get average lifetime of the progenitors to be 50 million years, and so on and so forth. Okay. So after having done that, after having rotated, this is the distribution of the minimum distance from the spiral arm spine that we see, which you can see that now it's it corresponds very well with this. Of course, the spread is to be understood in terms of it having lost the memory because of the random motions with which they travel for almost 10 million years, and that's a significant spread from where they were born. So that's the study that needs to be repeated after having had now the large number of pulsars available. If anybody is interested in it, they're welcome to write to me. So for example, these 3 estimates fell out of this study. As I said, co-rotation resonance radius of the galaxy, which is a sought after number. This is assuming flat rotation curve for the galaxy, which is pretty good assumption at farther distances. And then you have the correlation that one saw, implying that the mean lifetime of the progenitors is about 50 million years. And as I said, the population of the progenitors will be dominated by the lowest mass star in the in this category because of increased population of them. The number of stars with lower and lower mass are larger in number. So, and one can also get from the spread of the correlation one saw an estimate of what has caused smearing of this correlation, which otherwise would have been very peaky and sharp and tall. And one can get an estimate of what that is. So, so that's the, in a nutshell, what this project is all about. I'm happy to answer any questions on this or any earlier things that I've said. Thank you.
There are some questions, Desh.
Yeah. So actually on the chat window, that's a very nice piece of work, Desh. There's a question by Rohit, but that is not, it's, okay, you can answer that. And then there are a whole bunch of questions I've put. So can you see the question by Rohit? It's not exactly on this thing.
Okay, let me see. It's in the chat window.
Yeah. So could you provide any resources related to detection of gravitational waves by pulsar timing array method?
Yeah, so there are, I can look up, but if you look for search for words like pulsar timing array, and you will be led to 2 or 3 collaboration websites where the data have been made available in recent times. They have had releases regularly, and I think the data on the arrival times of pulsars for a large ensemble of pulsars are made available. People analyze this to see any presence of correlated variation in the location of the apparent location of the star, or the time it took to for the radio signal to travel. And using a grid of pulsars, one is hoping to separate out other contaminants from what might be a correlated signal in the arrival times, the deviations in the arrival times of various pulsars. So I can look up that thing right away as we speak, and sort of give you what kind of put pulsar timing array release, right? If you go to that, there is a paper on the archive itself which says the International Pulsar Timing Array second data release, okay, which will give you the details of the other portal links and so on. So they have first data release, second data release, and you should be able to download these data and play with it. There are also tools which I think the one that I'm aware of and probably still routinely use is a Tempo software, which was originally developed by Joe Taylor and his collaborators, which was actually used for doing the study that they did, where they saw the advance of periastron slowly in a in a binary that matched with the prediction of Einstein's theory of GR. So I think there are various places. The links are to I think the exact details of it will be given in some of these papers. I can sort of paste the links if you want on the chat window for you to. Should I do that?
Yeah, sure.
So the International Pulsar Timing Array itself, that site is copy it, and then let's see, where is the, okay. All right, so that's one of the places, IPTA, International Pulsar Timing Array. And you will see that basically the aim, defined loud aim, is a global galactic scale gravitational wave detector. Okay. And they have, I think, data release page right there, and also the accompanying paper describing all the details and so on. You can always get in touch with people in this collaboration to get some of your doubts cleared in case you run into any. Does that answer your question?
Rohit? Yeah, okay. He's fine.
Oh.
Then there were a bunch of questions I put up that are we assuming that all the pulsars in your sample have the same age?
No.
So how are you accounting for the difference in age?
Yeah, so once one, that is also going to cause the spread, okay?
Yeah.
But that spread is likely to be narrower than the shift because of the progenitor lifetime is expected to be much longer than the pulsar, than the lifetime as a pulsar.
Okay. Because there could be sorry, but I missed it. But otherwise, how accurately can one do the age estimation for pulsars?
Yeah, so the age estimation is good within certain factor, and one can actually take that into account also in shifting things, right? And I think we, if I remember right, we might have even done that. We would have compared that with the differently shifted uh, spiral arms, okay, based on the age, okay.
Okay.
I think and that can be done very easily, and so even that small spread can be reduced due to whatever is the shift corresponding to 10 million years.
Okay.
Plus minus 5 million years. So yes, and the estimate of the age is done from as a characteristic age estimate, which can be made by just assuming that pulsar was born with 0 period and has evolved to the present period due to slowdown associated with dipole radiation.
Okay. Another thing is when you made that plot, right, of the distance from the spiral arms, how do you know the exact location of the spiral arm?
So that's a model dependent number. We one has spent a lot of effort in tracing the spiral arms, okay, or deciphering the spiral arm structure in our galaxy. This is helped by a variety of studies. One of them is the study of dispersion measures that one has. One sees dispersion effect, which can be used to infer the how the electron density changes in different directions and so on. There are neutral hydrogen measurements where you will see concentration of the matter in the spiral arms. And so, of course, as you know, that we are not seeing this structure or galaxy from outside, like we have the luxury of seeing an extragalactic source. So we are inside it, and all the projection effects and so on have to be taken into account. And what we see is a the view within, from within, and so that disentangling of things of where the different arms are at what distance and so on is I think inferred largely from the neutral hydrogen measurements, because all and they have the tag of the Doppler shift associated with different distances.
So that would be the best source to, if you want to do a present study, for example, then you would have to use the H1 data and get the.
No, H1 data has gone into it, but that's not enough.
Okay.
Okay. So of course it does give you a certain handle. There are also enhancements in the non-thermal emission that you see where if you are seeing the spiral arm at the tangent, right?
Yeah.
You will get enhanced intensity there, like edge brightening. And so those are used to anchor the locations. So there are a variety of clues that are put together, even from the scattering of radio signals that you see, particularly using pulsars as sources behind. One has estimated these things. So, and also it's of course governed by the distribution of stars and so on,
Okay.
One can even sort of revisit this independently to see now that Gaia has all this other details.
Yeah, I'm actually thinking in reference to Gaia. That
yeah.
if
So
you
actually, again, you can use a better or more whatever robust model and even compare it with what was used earlier, and there is a huge scope for independent investigation. You're absolutely right.
And I have yet another question.
Yeah.
Is the 7M sun limit debatable, or are we quite sure about it?
Yeah, I mean, it's debatable to the level to which we can attribute that as the lifetime, I mean, the shift that we see. Okay. If that is about 60 million years and we can naively subtract 10 million years, or if it does do this analysis without, for every pulsar, depending on its age, we do the different shifts, which will reduce this spread somewhat, not completely, because it's dominated by the velocity spread rather than the age spread. We will get some number for the lifetime of the progenitor, and that correspondence again with uh, so basically one is using initial mass function for this stars and associated estimates of their lifetimes, which is gotten from typical behaviors that one has seen for a large number of stars.
Yeah, thanks. I can see another question by Geetanjali. Has this correlation been observed for large number of spiral galaxies?
Well, we do not know. Pulsars are not there in other galaxies that we have detected. There are, of course, pulsars there. So we can do this study only for our own Milky Way. But in principle, it can be done if you were to detect, these objects elsewhere, or you might have some other objects for which similar study can be done, which are visible, unlike pulsars in external galaxies. The same question can be asked about, pulsars is just one example. There can be another species of objects which might have some certain distribution at the present epoch, where they have, they might have memory of when they were born in certain places when the spiral arm structure was in certain other locations. And you can, use that profitably to estimate important quantities associated with their lifetimes.
But your pulsars will give you massive star formation, right? Your massive star formation.
Yeah, but it's dominated by the lowest mass that makes a neutron star because of the negative slope of the mass function.
Yeah. Okay. And then we have
it's a sum of all those, but yes, yeah.
So we have Abhishek, who is impatient to know what kind of results do you expect with the new data, with so much of new pulsar data. What do you expect if a project?
So the expectation is there have been doubts about this analysis in the first place, right? Because of the statistical uncertainties associated with it. So those can be cleared, or one can even prove this result wrong, right? We have no a priori expectation. Certainly, this study was affected severely by the poor sample size one had. And accounting for selection effects and those scale factors emanating from that is a major factor in the way this analysis will progress and the results you will get from it. Now, fortunately, there have been surveys which have single surveys that have covered large pieces of sky, like the Park survey, and one can use just and there it's very easy to compute for flux limited sample what volume you have sampled and what volume you should have sampled to get the entire population, and the scale factors are easy to compute. In earlier case, whatever few hundred pulsars one had as against a few thousand that are available today, they came from many different surveys. Not all details were available from about the surveys about the sky area that they covered, how well they covered, and so on and so forth, or what were their real sensitivity limits, which would affect severely the fraction that we scale factor that we compute as to what we have seen to what we could have seen if done if all the pulsars were to be observed. So those scale factors play a very important role. As you might notice that we have typically about 1 lakh pulsars in the galaxy. We are trying to infer something about them in general from few hundred pulsars. So the scale factors are typically of the order of 1,000 or something, and you make a small mistake there in assumptions of what a survey had in terms of its sensitivity, which part of the sky it really looked at, how the pulsars are distributed in our galaxy. That's an additional unknown which we try to make some assumptions about. So all these so one can ask this as a fresh question and have unbiased or less biased answers coming out.
Yeah, thanks a lot. So do we have any more questions? But it's a very interesting project, especially, I mean, you are a pulsar man, but if you want applies it for other samples also, that could be very.
I think it's a general question that can be asked about the memory of somebody who were born in certain places. We can do that study even for people moving from one place to another.
That's right.
Or other shifts that are occurring, systematic ones. Okay.
Yeah. Thanks a lot. I think that's a very nice paper. And actually, that's really the amount of data we have nowadays. A lot of work can be just done with the new data. Because ideas always live on, right? The idea is timeless, but the techniques and the data will change. So one can always use new techniques, new data, and continue with old ideas, which are really good. But yeah, thanks. That's really very nice. I'm going to go through this paper. And so if we don't have any more questions, maybe we can let Desh.
Yeah, so I can take leave.
Welcome to stay with us. But
no, if you're going to discuss details of what, how you would like to see the projects progressing and so on, that might be relevant in case somebody gets in touch with me.
Yes, actually, we can tell you now so that even you could suggest to us what we should do, because through these, we've had 4 months of classes, and in 4 months of classes, various people have presented various work, various possible projects, etc., things like that. And, obviously, we want it to be in a democratic way. So what I've actually done is on the website, I've actually provided a link to a Google Doc where people can freely put in their names and their ideas of their projects, which they would like to do. And they can list in that their names, their phone numbers, and their emails, so that then the others can go through what they've put up and, they can connect and start their work, keep us involved, keep the mentors involved, so that we know what they're doing. And our tentative plan was that is what would go on for the month of December and part of January. And then 18th January is the first weekend in Jan. So from 18th January onwards, we let students present what they did in their projects, as groups or individually as they wish. And accordingly, we can, give certificates to students who actually do projects which they present. I mean, that is what we thought of how to do it. You could obviously give us suggestions as to how could it be done in a nice. So I can actually show I can show the web on the website. I've made that page. But obviously, after people feed in things in the Google Doc, then I can import it to the page. So I'll give the link to the students about the Google Doc where they can directly edit and put their stuff. And others can also add their things, whatever they want to do. I thought that was a good way to go ahead. What do you say? You think it's a good way? Or...
Yeah, I mean, I have no specific opinion on it because you have probably more experience in doing this on the scale that you've been doing. But certainly shareable documents do make a big difference, and that makes it convenient for people to share instead of other things like Slack and so on, which gets scattered.
And it gets all lost. Yeah, you're right. It gets totally lost. So that's why this Google Doc is a good one where people can list.
That is certainly true.
And then use. And then I can import, after it has good amount of content, then it can be imported and put onto the website, etc. But I thought in that way, since we've already exposed people to a whole bunch of, projects and things which they can do, now they can put their mind at work and actually think of either doing that or doing something totally different also. There's absolutely no problem. Depending on what is the area, we can help them find mentors or mentor them to do it, right?
Yeah, so another problem with this online sessions are we don't know how far people have been receptive and what are their levels. Some of them are coping up well and they are writing separately, but there is no idea the sessions which we had, say with R or with Python or with AstroPy and other things, how much have they actually worked on that? Probably they didn't even have time. So we have to know what are the students interested in, how much have they gone ahead, and specifically which areas they need help in. Obviously, we introduce to them a variety of things, and there's much more to learn. And specifically when they start doing and they say we are having problems with a principal component analysis or regression, and then we can specifically come back to them and tell them how it can be done in R or it can be done in Python. That's not all. So we need to form these groups, and students have to identify what projects they are doing, and accordingly the respective experts who are with us, Desh is there, Shushan is there, various people, they can specifically tell them how to proceed ahead when they get a problem with an analysis of data or interpretation of that.
Yeah.
Because we can't teach the whole thing. It's not possible to teach everything to everyone. We are just showing them how to get information, how to do things, what are the tools available, and so on. So now the ball lies in the court of participants to get more proactive and goad us to tell us when and how, what kind of sessions we require. Another good news is,
I'd like to share a piece of good news that through OAD, this astronomy, International Astronomical Union Office for Astronomy for Development, we have another project which is coming up for next year, which we've already been, it has been approved and sanctioned. So it's called AstroSprint. And AstroSprint is essentially a continuation of this, in the sense we would have 3 proper workshops. So the first workshop is to be in March, which may be online. I think it will turn out to be online because COVID is still around. But then we have basic funding for 2 more workshops. One is in June, July, and one would be in October or November. And in June, July, it would be more of a working workshop where some of these students whom we are seeing online, we actually have money funding to give them travel grants, etc., for them to come to Hyderabad and or wherever we plan to have this. We can actually have a proper offline meeting where we can interact and discuss projects, etc. So the March one will be again with techniques and possible projects. In June, July, we'll actually discuss projects, form groups, etc. And then in October, November, the meeting would be of people presenting what they did in their projects. So AstroSprint would be a continuation of what this all has already set as as a stage for. And what we plan is that AstroSprint, we obviously won't repeat things which were done over here. We plan to go ahead. That means things which were already covered in Astronomy from Archival Data, we'll go ahead with more things so that participants can go through these videos and then add on to more material. We'll again have more people coming, more people talking, more discussions, more sessions. And another thing which we are also doing for that is.
So some of you probably are aware of this kind of a thing. This is called Raspberry Pi. Yeah, it's a computer by itself. And those who don't have laptops or PCs at home, and they have issues about doing data crunching and other things, you can use, these are for about 2,000, 3,000 rupees, and completely functional one. So we can help you all acquire this, set it up, and get the, yeah, these are called Raspberry Pi. Some of you probably have played around with it. And those who cannot afford a laptop or this PC, not to worry, these things are good enough to do most of the things. So we can, yeah, Priyam says that, yes, I have worked on this device. And yeah, so that's what I'm saying. Some of you probably have played around. You can do many things along. And it's a cheap thing. And it's a good process of learning.
And they can connect it to their TVs at home, right, as a monitor. And in that way have a complete setup. So
there is a question from John Mora. Professor Desh, tell us about your experience regarding computer simulations of pulsars. Desh?
Yeah, I had to unmute. I just forgotten that I had muted myself. Okay. Yeah, so I think what aspect of simulations of pulsars? You mean the population study related in terms of their distribution and so on, or simulation of pulsar signals?
Yeah. John, you can type your answer. Just type John, or you can speak if you want to.
It's midnight for John, but he sits every night, every Saturday and Sunday to attend these sessions.
That's very nice.
He's from Bologna. So Colombia. He's from Colombia. So John, you can type out or speak. John, can you hear? Or maybe we can just rephrase it that what kind of simulations have you done with pulsar data? Let's do that.
Okay, yeah. So there are a range of simulations that one does in the context of pulsars. Let me begin from closest to pulsar. One can actually, go and take the structure of the magnetic field. One can actually take a sheet of charges and estimate how the radiation pattern will look like as the sheet, progresses outward at relativistic speeds. You can do that elaborate simulation. And in fact, you can also do the simulation of the drifting subpulses by, creating spots in the magnetosphere base and see how things will evolve as a function of time as the pulsar rotates. And so this actually gives more insights into variety of issues relating to the special relativistic effects that you would see at larger distances from the star, particularly when the speed of co-rotation becomes comparable to the speed of light, after which, of course, the co-rotation ceases. And then there are interesting implications of it. So that's one thing. You can do this at whatever level of coarseness. You can take a bunch of charges and do this, or you can take assume some density and do it. And then, of course, you'll account for something which will properly account for their coherence factors and so on and so forth. Just a minute. I'm going to. There's a phone ringing.
John, if you're around, you can still type whatever you want to.
Sorry for that. Yeah. So, and the other simulations one can do is actually one can ask how, one can do that about this birth of pulsars, how they are kicked in different directions, and how they will be distributed. Actually, put a bunch of, right now, in fact, one of my students is doing this simulation of how pulsars are distributed after their birth. If they're born with different amount of kicks and so on and so forth, and then compare that with the present population and so on, and learn a lot about what the initial conditions were in terms of distribution and so on. So yeah, they're all doable. One doesn't require a huge amount of computing power for this. That's one thing I would like to stress. Those are easily done estimates and simulations can be set up very well.
Yeah. So Desh, thanks for that answer. But do you think this modus which we are operandi, which we are planning for projects, is that a good way to do it, or?
Yeah, I think I suppose individuals might have been tickled by various things into getting tempted to do certain things or try out certain things. And if they are able to
I should
express
also
that,
start listing out some, right? Maybe I can
right.
also start listing out some so that people who are a little confused, they can, choose from those.
Right.
So then they just need to see the necessary videos which are there referring to that particular project. They can see it once again and accordingly build up on it, right?
Yeah.
Because
I suppose other than me who came really at the end, others would have spelt out potential projects early enough.
Yeah. And some of them actually worked it out.
Correct.
Worked out things step by step. We had Tim Hamilton, who actually did 4 projects, and he actually did it totally step by step with everything. So in principle, a student can just change the object and do something similar. So his projects were like that. So there were different kinds of, people did it as per this thing. Sushan already has a group of people who have already started writing to her, and
right. In fact, I have taken her model to sort of follow. So in fact, I saw the correspondence that she had, or I think the small video that she had, announcing the project and then calling on people to write to her. And
that's right. So a bunch of people have already written and are already at the job, doing that business. And
so I also invite people to write to me who might be interested in playing with this particular aspect. And I've chosen this particular aspect, while lots of things can be done with pulsars, because of the timeline being short and something that can be done in a reasonable time.
Yes.
Yeah.
Data might be readily available.
Yeah, it's a very interesting this thing. I've always.
And in each group, if we can keep us in the loop, so then we will know how it's going and the progress and so on.
Yeah.
Some sessions actually which we had were more tool based, like in the sense Python, AstroPy, those kind of things is not, they didn't have direct projects because those were tools. Topcat, ESA Sky, Aladdin, they were more tool based. So then whoever does whatever can use those tools. So those were not like that. But yeah, we have a good spread of things.
Yeah. And then for the participants, see, there were certain things which have not been spelled out specifically, but like we spoke about galaxies and morphologies and so on. So there can be projects which can be done on that as well. Fitting of profiles, looking at the morphology
did touch upon
of
it a little bit.
Yeah.
Ajit did touch upon it.
Professor Ajit had spoken, Kibhavi, and if somebody wants to do on that, there are certain software like GalFit and all which are used for fitting profiles, or even using Python and R, you can fit profiles to galaxy data and so on, and see their structures and and so on in an interesting way. So if somebody is interested, then that group, we can start moving towards that. We didn't show them how GalFit gets going, but it's something very simple. You can download from the net and start using it. The nuances, simple nuances which are there, which we can show you.
So what I'll do is on that projects page, even the Gaia projects, I can start listing them over there and people can have a look and do that. And obviously, like, we are looking forward to Astro Sprint, because that's when we hope we can have offline sessions with all of you all, and with Desh, with whoever, the other friends who will join us, because there is nothing to beat offline, right? So we do hope that when we have those offline sessions, it would be even better, right? You wind up. So do any of the participants have anything to say, since this is our final session with sessions? So does anybody want to say something, or can you share the link of the Google Doc? Like, give it on the website. I'll share it over here too. Yeah, I'll do that.
Is there President Staff Formation?
Yeah, I'll list. Sorry, I am the one who have not listed my projects. I'll list mine. I'll put it on that Google Doc. Sorry, I haven't done it. I'll do that. Yes, they'll be on star formation, on star clusters, on. I'll put that. Yes. Does anybody want to say something or ask something or comment on simulations? Simulations means what? What simulations do you want, Priyam? What simulations are you talking about? In dynamics and observations, and in what?
We can do something on n-body simulations, dynamics of, say, star clusters or galaxy dynamics. So if somebody is interested, then we can do that. So Priyam, just specifically ask, what simulations are you talking about? Simulations can be of everything or anything. So we can handle n-body simulations, simulations of solar systems, and we are comfortable with certain software, and we can teach you. Yeah, we didn't do it in this session because already we have come a long way, and we thought that now we should get down to business, and we can have something on. Do we have projects in Gaia DR3?
Yeah. So I'll put up the Gaia ones. I'll put up the Gaia ones on the Google page. I'm sorry, I haven't yet put it. Yeah. So the DR3 will be EDR3. This is the early data release, which will be out on 3rd December. DR3 is going to come out in 2022. So this is EDR3. Deshpande sir's email. I'll just give that to
you. Yes, if you can just type about your email address here. We do have it, but
yeah. Maybe I should put a table up of all the speakers and their emails and like
that. Priyam, if you are interested in simulations, say galaxies, merger of major, minor mergers, and then effect of, if you have gas-rich disk, and all these can be done with gadget. And one of my students is working on that, so we can get you involved in that. Yeah, we can. So if you are interested, do mention. But we thought we'll save this for the Astro Sprint. That's why we didn't touch upon the simulations one. We thought for our next project, we will look into those.
Okay. So, yeah, I think, yeah, Avik, you're right. What I'll do is I'll put up a list of all the speakers and their emails and stuff. So I'll do that. I'll have to make a table and put that in. I'll do that. But most of them, if you just Google and look for their, their institute address and all that, you'll anyway find it. But I'll put it up. No problem. I can do that. And
all our participants have been extremely good in the sense that when we have these online sessions, most of the time we see that there's a lot of noise coming from behind. They don't know when they are muted, when they are not. The decorum here was extremely good and people were very regular. So we want to thank you for all that.
yeah. Thanks for your participation. Thanks for your encouragement. And obviously, we have to still go on, right? So this is not the end. This is just the start. So I'm going to do my homework of giving you all the speakers, addresses, etc. And please start filling up that Google Doc where we'll actually put in the things. So one link to the Google Doc is already there on the website. If you see the Astronomy from Archival main page, there is a thing which says projects. Okay. If you click on that, that links to the Google Doc. Okay, otherwise I will anyway share that with you, the link to the Google Doc, right? So, yeah, thanks Gitanjali. We thank all the speakers also on your behalf and everybody else's behalf. Thanks Mudassir, thanks Karthik. And we want to hear more from you all, and we also want to see you all in January when you all present your projects, okay? So please do that. We are trying to do it in a democratic way. Nobody's forcing you for anything. But please decide what you like and accordingly go ahead.
And see, we are repeating again. It doesn't mean we can't meet next weekend.
Yeah.
Yeah. If you all want to have some more sessions,
yeah,
we can meet again. Yeah. Not just Saturday, Sunday, but on other days. So on Telegram, just write to us and say when we should have one more session. We can again have it.
Yeah.
And yes, there are certain things which we had promised to do, and I will do it. Handling noise in R. Yeah, I think Avik had asked for handling noise. So we will do that. I'd been reading about that. He was asking about handling Gaussian noise in R. So the thing is, we are not experts in this area. We have used most of the tools which we spoke about relevant to our work. So there are things, so I'm not an expert in R, but I'm reading up and looking up, and I have reached a stage where I can have a session on noise, how to handle noise in general, but how to specifically handle Gaussian noise and all, I'll have to do a little more. So this week I should do that, and either we'll have a session or we'll make a small video and put it up. Okay.
Fine. So thanks everyone. Then we'll wind up now. And thanks Sargam, thanks Mritika, thanks Rohit, and Vandana too, Namrita. Thanks everyone. And we will anyway be in touch. We are not yet done, right? So it's not time for bye-byes or anything. We are anyway meeting again.
Yeah, you can unmute and speak some of you, so that will be better than reading on chat window. So you can unmute and critically say what has to be done, what has been done.
Yeah, what?
Somehow we Indians tend to just praise each other and not critically analyze. So it's important we know the shortcomings too.
Yeah.
Can you elaborate how the project will be? I mean, will there be a report after the project?
Yes, yes. So that's what I said, right? The weekends from 18th January, 18th, 19th, there are 2 weekends from 18th January onwards. That's when you all will present what you have done so that we can see what you have done and everybody can share that, right? So
that will be a PowerPoint presentation,
yes,
PPT presentation.
Yes. As you wish. It can be it will be a PPT presentation. It would be good also if you'll give us write-ups of what you'll have done, and that can be shared with everyone. We'll keep it up online on the website so anybody and everybody can have a look at that. Yes. So we want you all to present your project in the form of PPT with a video as well as preferably a write-up about what you actually did with the project, right? And then we'll take it forward afterwards with AstroSprint when we have those workshops. right? And this would be helpful for all other students. See, another purpose of doing this thing is that a lot of you who may want to join for a PhD program in the future, right? This is an opportunity for you to actually do a serious project, which you can then use later on for your applications or your way forward in a PhD, as well as to give you an exposure of what is the research process and how do you actually do it, right? So we'll share this common knowledge with everybody. Yes, so you will present it.
In fact, we can probably have a session on report writing, project report writing. We can have a small session on how you do the referencing bibliography, maybe using LaTeX or whatever. So you can actually do that. And you should think of continuing this with your mentors so that you can publish it. If you can publish it, that will be still better for you.
Yeah. So,
but by January mid, you will not publish it, but you should reach a stage from where you can carry it
at least
ahead.
have a well-defined problem and a well-defined, plan of action, what to do. Yeah.
Ma'am, are you going to list the problems and mentor names?
Yeah, on that project page, I will put it up, right? I've not yet done it. I will do it. Yeah, and I'll share that with you. So on the website, you'll find the link for projects. When you click on that, you'll see it. I've not yet put it. I've just made the page. But yes, I'll put it. And all of you all are free to edit it also. So if you want to list a new project or something else, you're most welcome to put that up. Right?
Sorry to interrupt. I might have to leave. So I'm leaving formally.
Yeah, we are done. We are done. Okay. Thanks a lot. Thanks a lot, Desh. Thanks so much.
Thank you. Bye.
Yeah, bye.
Yeah, there is a request from Dinesh. Aditya, it will be helpful to have more sessions on R. Yes, so we can have more sessions on R. But one thing I want to show you is there are a lot of resources available, and it is important to know how much have you already tried on. Okay, so I will share screen and okay, and very good. See, R is all over the net, but if you can go, if you are looking for statistics, so you just look for astro statistics and astrostatistics, and I've given the link in Telegram, Penn State University. So Center for Astrostatistics at psu.edu. See, you'll hit upon this one, and here is the book, which is a very good book by Eric Ferguson and Jogesh Babu. And this book is available. Probably it's a bit expensive, but you can buy it. It's a good book. And there are some R scripts which are there. So if you go into this R scripts, there are certain scripts which you can download it and run them. You can just change it for what you require. If you notice that there is something for plotting, plot upper left panel, probability distribution function, computing mean integrated square, and so on and so forth. So there are these scripts which you can cut and paste. Say, for example, chapter 7 is regression. So this book is not a very simple one. It is a serious book, but these scripts are pretty good. You can take it and you can change the data set, what you require, and do the analysis the way you want to. So there's a host of scripts which they write right there that you can download it and put it in your R console and do it. Okay. Apart from that, there is this data and tutorials. if you go here to go to that link, you will see our tutorials. So they are introduction to our miscellaneous concepts in our descriptive statistics, exploratory data analysis, regression, cluster analysis, all these are there. So if you go to some specific, say, introduction, then you have these things right here. So the question is whether we redo something which has very beautifully done or not is one question, or uh, you get into these things and see how it is going, and if you have problems and issues, then we can come down and discuss it. Yeah. Or what we can do is similarly. So this whole web page is for astrostatistics, Center for Astrostatistics, and you have Markov chain, Monte Carlo ones, and then there are various summer schools which are there. Some of them probably are not open to all, but uh, yeah, so it's a good idea to look into this and do it. And other than that, uh, Python is being very programming is being used very effectively to do similar things, same things, statistical analysis and so on. So you choose the way you want to go, and it's not that I'm trying to wash my hands off. We can surely have more sessions on R. But one thing is the things which we did, have you tried them? If you have had any issues, if you're having problems doing something, which we have to know. Uh, Online, it's something total black box, and we are unable to understand what has been done, and you understand. So we need some kind of a input from you all. Anything in chat? Yeah, so are there any things to be asked?
I would like to add something, sir.
Yeah.
This is Avik. Probably while we start doing the projects, we would better come to understand which like are or whether other things are required, and
Exactly.
we will then. One thing as a feedback, I want to say that now, as I am through with all these ESA and Aladdin and all these tools of astronomy, whenever I read something, so I can just go there and look out what suppose I'm seeing star formation region in different bands, so I can just go to ARSA and see that which are the bands actual data which has come out, and understand it more better, just not only looking the picture in the text which is given. Thank you for that, and thank you for the whole.
Yeah, exactly. That's the idea, because once you get into with your projects, see, till this time we were telling you what are the ways of going about, what are the resources, where is the data sitting, how do you get it, and now that once you start doing it, and specifically when we need certain problem tasks and tools, then we can get down and discuss them separately. Yeah, you're absolutely right.
Okay. So like I said, it's not bye-byes or anything. We are going to be very much in touch, and we'll continue the interaction. Like Sir said, if you want to have more sessions, we can have more sessions. There's no rule. We don't have any rule book to be following. So we can have more sessions or anything. So you're most welcome to write to us on Telegram or email or whatever you like. And accordingly, things can be organized. But the plan, like I said, is that second half of Jan, you all present to us what did you all do with the material you all got, right? I'll try to add in the projects on that page, Google Doc, etc. And till then, you guys also add in there and decide. Amongst yourselves also, you can decide what projects you want to do and we'll go ahead, right? So let's go ahead into a new phase where now you start the work, right?
Because see, this is essential because if we continue, then many of you will go from weekend to weekend thinking now we have to attend the class, we have attended, job done. So now you know that you are on your own, you are in the swimming pool and you have to swim. Yeah, so, and now you have to, yeah, so.
Yeah, so we'll wind up with that and say thank you and bye-bye for now. Like I said, this is not some big bye-bye. We are meeting again and we'll keep in touch. Anybody else want to say anything? Anything more? Thanks. Yeah, thanks everyone. Any critical comments which can help us to orient, because this is the first time we've done so much of this online teaching business, which was never our, we do live classes. We don't do this.
Nijam sir,
Yeah.
yeah, this is Rohit. Sir, I
Yeah.
was thinking that if we could have a few sessions on dealing with noise in data, which means if we go through the statistics of noise,
Okay.
white noise, white Gaussian noise, and sometimes we also encounter non-Gaussian noise also.
Okay. Yeah.
In dealing with time series data is a bit of a problem. So if once the statistics are cleared, then I guess it could be much better in order to deal with such noises.
Yeah, sure.
Okay, sure. Like I told you last time you had asked for it, so I have been working, reading on that. I am not an expert in R. We have used it. We have attended one of the workshops with the Penn State people.
Okay.
We have used it, but so I'm reading up on that and working out, and
But, yeah.
we'll have a session. Yeah.
But Nijam sir, we can use R only if we are doing very high-end statistical work. But I guess the work that we can do can also be done in Python very easily in terms of statistics.
Correct. Yeah.
Yeah.
In fact, Python is coming as a very strong contender to all statistical packages because with critical lines of code learn fast, you can do a lot of work. So even SPSS people are running for their thing because Python is coming up strongly. And the good thing with R and Python are the online communities are very powerful, very strong. You can get answers to most of your questions right away. In R, I showed you how effective is the help facility. You say help and that function name or that command and it tells you. Or with a question mark, you put something and it gives you right away gives you. Yeah, so okay, we'll handle that noise.
I have been reading something on noise, like how do you deal with noise. So I will, what I'll do is maybe I'll put it on Telegram or maybe I can mail you some resources and then we can.
And all of you all also, you are most welcome to present and share. If you would like to present, you think you have a deeper understanding which you would like to share, which would be helpful for the others, then you are most welcome to present it, right?
And ma'am,
Not following any rule book or anything. We are free.
sir, I may trouble you in between because if suppose I'm working on something in dealing with noise and if I'm stuck somewhere, so I will mail you like what's the issue is
Yeah, sure.
if possible.
Yeah.
Yes, ma'am. Okay, ma'am. Thank you.
Yeah. So, yeah, thank you, John. Thanks a lot. He's written. And I'll try to handle the subtitles issue. I'm not very good at doing it. Some videos it's not happening. I don't know. So that's John Mora, one of our participants who's from Colombia. And he's been asking me to activate the subtitle thing in YouTube so that he can then put Spanish subtitles. So you'll see lots of the videos which we have, you already have subtitles, so you can actually convert it to whichever language you want. But sometimes I do have a problem in some videos, it doesn't happen. I don't know why. But I'll try. I'll continue trying doing that. I think now it's automated. I'll just check. Yeah. So thank you, everyone. And bye-bye for now. And we'll keep in touch and hope to hear from all of you all. Right?
And if you are planning any special sessions, we'll
Yeah.
put it in the Telegram.
Yeah.
Okay.
Okay. Thanks a lot. Bye-bye. See you.